Estimation of IBM's annual returns and annual risk by using Excel, R, and Python. Agenda. In this short video, I'll discuss the following topics. Topic number 1. I'll explain several basic concepts, such as percentage return versus log return, how to measure total risk, how to analyze our risk estimation based on daily or monthly returns. Topic number 2. I'm going to show you how to use Excel to estimate annual return and annual risk. Topic number 3. Using R instead of Excel. Topic number 4. Using Python software. Topic number 1. Several basic concepts. The first concept is percentage return versus log return. Assume we have invested $100 to buy one share of any stock A. At the end of investment horizon, we sold the stock. Assume the selling price is 110. So P0 is 100, P1 is 110. Percentage return is simply P1 minus P0 divided by P0 equals P1 over P0 minus 1. In this case is 110 minus 100 divided by 100. So it's 10 divided by 100 is 10%. Log return is simply the log P1 over P0. I'm going to calculate using R. There are some good properties for the log return. The log return of a long period is simply the summation of log return of short period. For example, the annual log return equals summation of 4 quarterly log return. The quarterly log return is simply the summation of monthly log return. The monthly log return is simply a summation of weekly log return and also daily. So the annual log return is simply the summation of log daily return. So this makes our calculation of annual return very, very simple. C. We can convert from percentage return to log return or vice versa. I'm going to show in a minute how to use R to convert 10% to log return and the log return to percentage return. The last concept is we use deviation of return to measure the total risk of a company or a stock. So usually professionals and researchers, we use daily or monthly data. Then we have historical daily data. We are going to download IBM's historical daily price. Then we calculate daily return. The standard deviation of daily return will be our risk. On the other hand, we can also download the monthly frequency data. Then we calculate standard deviation based on monthly return. If we want to calculate annual risk, so SQRT square root of 252 times standard deviation based on daily return. Alternatively, SQRT square root of 12 times standard deviation based on monthly return. Based on our previous assumption, we invest $100 and so P0 equals 100. Okay, and suppose we spend $100 buy one share. Our selling price is 110. Okay, so this is P0 100 and P1 is 110. Our percentage return is P1 minus P0 over P0. Okay, so this is 10%. Okay. Alternatively, we can define as P1 over P0 minus 1. We have same result. Okay. For the log return, so log return equals log P1 over P0. the log return. So actually, this log return is natural log. You see, so exponential 1. So this is exponential 1. So this is, I'm going to show the log exponential 1. We got 1. So this is actually log return, and from Excel, from R is natural log. Okay, the percentage log will be, so this one is log 10, it's percentage log. It's different, a little bit different from Excel. I'm going to show you when you use Excel. Okay, so log return, so we have percentage return is 10%. We have log return is 9.531%. Okay, and from percentage return, okay, log percentage return plus 1. So this is I called plus 1. So this is plus 1. Okay, so from percentage return is 10% plus 1, we get log return. Okay, from log return, we apply exponential function. So this I called minus 1. Okay, so percentage return plus 1, then take a log, and exponential log return minus 1. So plus 1 from percent to log return, minus 1 from log return to percentage return. So we are going to use this formula. So basic idea is we download the historic daily price data. We calculate daily log return. Summation of daily log return will be annual log return. Then we apply exponential function minus 1. Then we will get percentage annual return. So this is logic behind why we use log return instead of percentage return. Topic number 2, how to use Excel to calculate annual risk and annual return for IBM. At step 0, okay, I'm going to show how to download the data from Yahoo Finance. First one, we go to finance.yahoo.com. We enter IBM, International Business Machine. In the middle, we click historical data. And for the time period, simply click max. Okay, because this is daily already, just apply, then download. I'm going to use this data set for both R and Python. For Excel, R, and Python. Okay, the first step 0. Okay, this is step 1. I'm going to save as a text file. Excel file. Okay, so save as. Because the original data set is CSV, I simply choose. Okay, I'm going to save it. Okay, says just remove. Okay, replace. Okay. I'm going to use Excel and pivotal table to calculate total return and annual risk. Okay, I'll do it separately. Okay, and step 1, I'm going to calculate annual risk based on daily return. Okay. That's step 1. I'm going to calculate log return. Okay, and for the Excel, okay, I'm going to show you. So this is equal exponential 1. So this is exponential 1, and natural log is ln. So ln. So this is 2.71a. So this is 1. Okay, so this is formula. So I use ln instead of r's log. Okay, so this is ln instead of log. Okay, so first one I'll calculate log return. So log return will be ln. So ln and adjust closing today divided by adjust closing yesterday. Okay, then I double click here. Okay, so this is I can highlight all these columns. I only need like date and log return. Okay, because I'm going to calculate annual, so I need a year. So this is a year. I'm going to use year function. So this is date variable. So this is I'm going to show you the formula. So this is formula. So this is simply the year function applied to the date variable. Okay, double click. Okay, so this is a daily log return. Okay, and so let's calculate annual log return in 1962. So let's manually calculate one annual log return. Again, as I mentioned, it is simply the summation. Okay, summation. I'm going down to the 1962. So eventually we are going to compare. So this is September, November, and December. Okay, so this is December 31st. Okay, so this is December 31st. I'm going to close it. Okay, I'm going to close it. So I'm going to show the formula. Oh, it's not. Oh, this is calculate total return. Okay. Yeah, so this is annual log return. Okay. Then we are going to calculate annual percentage return. Okay. So this is annual percentage return. It's simply exponential annual log return and -1. So it's +1 -1. Okay, I'm going to show the formula. Okay, I repeat the concept. Okay, so basic idea is we calculate daily log return. Okay, summation of daily log return is annual log return. Okay, then we apply exponential function to the log annual return -1. So this is our annual return, annual percentage return in 1962. Okay, I'm going to highlight. Actually, I only need these two columns. Okay, yeah, I just highlight all and Control Shift down arrow. Okay, highlight the complete data set. You can use insert, pivot table, and highlight. Okay, so usually I highlight my data set first. So I insert. On the top left, there's a called pivot table. Okay, I click pivot table, select a table arrange. It's new. Okay, choose a new spreadsheet. Okay, on the right hand side, you see we have all the variable. We care only about two things: is year, is log return. So based on year, we are going to calculate summation of log return. Okay, I'm going to drag this year to the rows. Okay, so on the left hand side, you will see so 1962, 62, 1963, 64, and continue this way. Okay, so this is so-called row labels. Okay, then I'm going to drag log return to the summation of value. Okay, summation of value. Okay, you see here, summation of log return. Okay, for some learner or student, you'll get the count. Okay, if you get a count, you on the top left, on the right bottom, you click the summation of return, then you will see the value field setting. I'm going to make it count first. Okay, suppose your original is a count. So count of log return. So 251, 251, 253. So actually this is number of trading day in 1962, 1963, and 1964. Okay, I'm going to click here. So count of log return. Then I click value field setting on the right bottom. Then I choose summation. Okay. Then I'm going to copy and paste. I'm going to copy and paste and as a value. Okay, so this is I'm going to copy to the spreadsheet 1. Okay, spreadsheet 1, I'm just choose any location. So I paste as a value. Okay, so actually, so summation of log return as I mentioned. So actually this is annual log return. Okay, so this is, if you look at, if we compare these two values, okay, 38229, they are identical. Okay, and so here, because this, so this is percentage return. Okay, the percentage return will be exponential, annual log return minus 1. The percentage return is exact same. Okay, so I use purple. So this is also purple. Okay, and I'm going to copy and paste. Then we got all the annual percentage return for IBM. Okay, I'm going to, so let's calculate annual risk. So annual risk. Okay, so so I'm going to calculate percentage return. Okay, the percentage return will be adjust closing price today divided by adjusted closing price yesterday minus 1. Alternatively, we can use this number minus this number and parentheses divided by adjust closing price yesterday. Okay, so this is return. Okay, I'm going to, yeah, so there's no way I can, okay, so I'm going to, okay, I'm going to copy, put it here. Okay, so I don't need this part. Okay, so this is, again, I'll just double check. So this is, oh, this is not correct, equal F3 minus F2 minus 1. So this is, I'm going to show the formula. So this is the formula. Okay, so this is F3. So F3 is January 3rd and January 2nd minus 1. So this is return. Okay, just click and return. Okay, so actually I only care about these two columns. Okay, I'm going to Control Shift down. Okay, again I use insert pivotal table. I have another spreadsheet. Okay, so same thing as before. Okay, I'm going to click year to the number of the row. You see 1962, and I'm going to drag this percentage return to the value. Okay, to the value. Okay, again it will give me the summation. Okay, I don't want summation because I want standard deviation. Okay, so this is value field setting, and I'm going to here. So this is standard deviation. Okay, just click OK. So this is a standard deviation based on daily return. I'm going to copy this part and back to my previous spreadsheet. Okay. Okay, so here, okay, I'm going to paste it here. I paste as number. Okay, and again, so this is standard deviation of return based on daily. As I mentioned, we use SQRT 252. So this is we convert standard deviation based on based on daily return to annual. Okay, risk. So equal SQRT 252 times standard deviation based on daily return. Okay, so this is I'm going to So this is annualized risk for IBM in 1962. So actually we can manually calculate as well. Okay, so this is STD on daily return. Okay, so STD on daily return. Okay, so we are going to, okay, so this is equal STDV. So STDV, we find the daily return only for 1962. September, October, November, December. Okay, so this is we have the, yeah, so this is we close it. Okay, if you compare this value, I'm gonna use red one, this value versus this value, they are identical. So 0.020695, and I'm going to show the formula. Okay, so this is a formula. Okay, so we calculate the daily percentage return. Then we apply STDV function. We calculate standard deviation based on daily return. Okay, then we use SQRT 252. We times this standard deviation. Then the risk for IBM, annualized risk or annualized standard deviation for IBM in 1962 is 33%. So these two values are the same. Okay, so this is how to use Excel to calculate annual return. So the annual return for IBM in 1962 is negative 31.77%. The annual risk for IBM in 1962 is 32.8526%. Topic number 3, how to use R to calculate IBM's annual return and IBM's annual risk. Okay, I'm going to use the same downloaded data set. Okay, so I use file, choose. Okay, in file, I know the location of the what is called download folder. Okay, so in file equal file choose. Okay, file choose. Okay, so I know it's C. I'm going to use this data set again for my, so for use Python. Okay, so this is download, and so this is IBM. Okay, IBM, clicks open. Okay, in file. Okay, I'm going to use the, oh, this is Excel. No, it's not correct. Okay, I'm doing it again. Okay, so in file, choose, and so this is user. Yeah, I download, then I generate the Excel file. So this is download. This is correct one. Okay, so open. So in file. Okay, I'm going to use this one, IBM.csv for my Python code. Okay, so X, so data frame equals, I can use X equals read CSV in file. Okay, so this is I can use X. So this is my data set. So this date, open, high, low, close, adjust, close, and return. I'm going to use adjust closing to calculate percentage return and also calculate log return. Okay, and the first step, I'm going to generate a true data variable. Okay, so this is DD as the first one. I want to show you. So this is not a true data variable because I'm going to pick up the year. Okay, I can use A equals X date. Suppose I choose the first one. So this is first one. Its first is 1962-01-02. Okay, I can use type of A. So I know this is a capital. We cannot add anything. So A plus 10. If A plus 10, and then because we cannot add 10 to a string, a character variable, or string variable. Okay, so as date A. Okay, because this is a standard input, we don't have use format. Okay, the complete code should be format equals %y hyphen %m hyphen percentage date. Okay, so this is, suppose let's call it B. So B plus 10, B plus 40, so this is B, right? The B is January 2nd, and B plus 40 is January 1962, February 11. Okay, so this is, so let's call DD equals S date. So this is X date. Okay, so this is, so let's add DD to the, so because, so let's use DIM X. Okay, so we have seven columns. So let's call it X colon 8. So let's call it column 8 equals DD. So H. Okay, so this is actually is true date. Okay, I'm going to calculate return, and okay, so let's calculate log return first. So let's use so I'm going to calculate log return. So I'm going n. So n is number of the row. Okay, so number of the row and x. So number of the row. Because when we calculate log return or return, we are going to lose like 1 point because we are going to use this number. And so there's no return for the first day because this is first price. We don't have the previous price. Okay, so this is return. So equals x adjusted the closing price from 2 to n divided by x adjust closing price from 1 to n minus 1 and minus 1. So this is a percentage return. Percentage return is log adjust the closing price 2 to n. So let's look at the return. Okay, so first return is 0.00878. So let's try it. Look at it. Okay, so this number divided by previous number. Okay, previous number and minus 1. Then we got identical result. Okay, so this is a percentage return. Okay, exactly same. So let's use log return. So log. So this is log return. Okay, again it's a log. The first column divided by the second one, and we close it. Okay, so we close it. So this is our log return. Okay, so let's look at the how many. Okay, return and log return. Okay, and n. You see, we lose 1 point. We lose one observation. Okay, log return we have 15,075. Log return we have 15,075. We lose 1. Okay, so let's call it x2. So x2 equal date frame. Okay, so x, this is from 2 to n. Then we plus return and log return. Okay, so we add okay, I'm going to add a year. So the year equals, so this is, what is my DD? So format DD is my, so this is percentage Y. Okay, I'm going to add a year, okay, because this column, I don't need this column, actually I need a year, okay, so this is a year, okay, format, this is format, okay, format, okay, okay, so this is, so let's call it X2, data frame is X, year, log, return, and log return, okay, so actually, oh, I need 2 to n because we miss one observation. Okay. Oh, the year I should also from 2 to n. Okay. Okay, so this is X2. Okay. So we have, you see we have year, we have return, and we have log return. Okay. Now we need to calculate, so for the annual, we are going to use this one. Okay. Oh, I think we can make it simple. So we just need, we don't need x. Okay, so let's make it simple. Okay, so x2, we only need year return. Okay, so this is much simpler. Okay, you see we have year, we have return, we have log return. Okay, so let's make it nicer. Column name. So column name x2. So this is, so let's use names equals column names x2. That names 1. So let's make it better. So let's call it year. Okay, head x2. Okay. Oh, I forgot column names x2 names. Okay. Okay, so we have year, column year, we have return, and we have log return. Okay, so let's calculate standard deviation. Okay, standard deviation will be, we calculate standard deviation. Okay, suppose we calculate standard deviation just one number. Okay, so this return. Okay, so if we use standard deviation return $2, then we calculate this one. Okay, so this is, we use all the observation, we calculate, so how many observation? Number of the row, so this is x2. So we use 15,075 observation, and so this is not object. Our object is based on the year. Okay, so actually, so I use annual risk. Then we can use a function called aggregate. So aggregate. So aggregate, we are going to use x2, and we're going to aggregate return. So we are going to aggregate the return by equals, so we are going to by equals and x2 year. Okay, we are going to by year, and function will equal SD. Okay, so SD. Okay, so this is annual risk. We are going to calculate return by applying function called standard deviation. We just apply here SD, and so by year. Okay, by year, then we enter. Okay, so this is by must be a list. So this is not a list. Then we add the list function here. So this is, so we add a list by list equal this one. Okay, add annual risk. Okay, so this is our, so actually this is a year, this is standard deviation based on the annual data, right? And so let's, this is annual risk. I applied the wrong X. Okay, so let's annual, So this is the standard deviation based on daily return. We have to time this value. So I'm going to manually calculate 1. Okay. So this is annual risk dollar $x. Suppose let's choose first number. So this is first number, and we can manually times SQRT 252. So this is our annualized risk. Okay, then we can use annual. So we know the annual risk is we have 60 years. We have 2 columns. Okay, so let's add another column called the column 3. So column 3 will be annual column 2 times SQRT 252. Okay, annual risk. Then we have 3. Okay, so this is a year. This is standard deviation based on daily return. This is annualized. Okay, to make it much nicer. So column name, annual risk. So this is C year. So this SD daily and SD annual. Okay, so this is our final result. Okay, so this is 1962 standard deviation daily and the standard deviation annualized. This is annualized. Okay, let me summarize the code. Okay, and the first one we identify the location of the IBM input historical daily CSV file. We read it and we find how many number of a row. Okay, then so objective of these 2 lines, we want to calculate a y, a year variable, because we are going to calculate the standard deviation by year, 1962, 1963, and here we calculate return, and this is for calculate standard deviation. Okay, log return. So we are going to calculate annual return. I'm going to use this one later. Okay, at this moment we don't need it. Okay, so this is this is not correct. Okay, I'm going to, so this is because we calculate percentage, this should be return. Oh yeah, we add this log return and the log return. Okay, and so annual risk, we apply this formula. Okay, so this is called aggregate. So aggregate, we are going to use return because this calculates, we calculate standard deviation. Okay, so this is we use a list, calculate based on the year. Finally, we have to add another column called annualized. So this is x2 will be the standard deviation based on daily return. We times square root of 252, and then we make it nicer. We add column names. Okay, so this is our final result in terms of annualized standard deviation. For the total annual return, okay, and we simply modify this line. Okay, so this modify, and so this is for annual return. Okay, for annual return, and the first step we calculate log return. So this is log return. We aggregate according to log return. Okay, same thing by year. Okay, the function will be summation. Okay, the summation. So the summation of daily log return will be our annual log return. Okay, I'm going to copy and paste to R. Add annual log return. Okay, so this is our annual log return. Okay, so this is log return, actually this annual log return. Okay, then we can add another column. Okay, so it is called annual log return. So we can call it. So actually, it's a good idea we call the return instead of the log return. So annual return. Okay, annual return. So this is annual return. Okay, so this is log return. So we are going to add another one called the annual return. So let's call this dollar sign. So let's call it return. Okay. So return will be exponential annual return, and so this is x. So this is -1. Okay. Add annual return. Okay, so this is our final result. Okay, so let's make it better. Colon names annual return. So this is equal C year. So this is log return. So this is percentage return. Okay. So this is our final result. Okay, so this is year 1962. So this is annual log return. So this is annual percentage return. This is a complete R program I'm going to explain. Okay, one more time. Okay, and the first one we identify the location. So this is the user and download IBM.csv. We can use like / just one, / twice. Okay, we read it and we find how many number of observations. Okay, and for these two lines, so actually we want to get a year because we want an aggregate. Suppose we calculate risk based on each year, and also we calculate total return for each year. Okay. Next two line we calculate percentage return and versus log return. Okay. So percentage return, and so we use adjust closing and 2 to n and 1 to n minus 1. Again, after we calculate this one, we lose one observation. Okay, we lose one observation. And for this one, okay, we combine because we only care about the year. So we only care about these three variables: year, return, and log return. We don't care about adjust price anymore. We don't care about the date. Okay, so we merge them together. So this is because we know the year is n, and return is n minus 1. The number of observations is n minus 1, and log return is also n minus 1. So the year should be from 2 to n. Okay, then we give them some appropriate column names: so year, return, and log return. So year x2 is daily frequency. Okay, then we calculate when we calculate annual risk, we apply aggregate function. Okay, so this is we use return column. Okay, and we use by each year. Again, we have to make it a list. We calculate standard deviation. So actually, this one is identical to this one. The only difference is we calculate summation and we use log return. Okay. Again, so this one we calculate annual return, and we have two columns. One column is year, another column is standard deviation based on annual data. Sorry, based on daily return. Okay. Then we add the third column. Third column will be annualized risk. So it's 252 times, so this is x, second column. Okay. Finally, we have our final result. Make it nicer. We add appropriate column: year, standard deviation daily, and standard deviation annual. So this is our final result. Okay. So this is standard 62, standard deviation based on daily return, and standard deviation, annualized standard deviation. Okay, so second part is almost identical to this part. The only difference is we use log return because log annual return is summation. So it's a summation of daily log return. Okay, the middle part is the same thing by the year. So this is log return, annual log return. So this is applied exponential. Then we got percentage return in 1962. Okay, so this is final our code. Topic number 4, how to use Python to calculate IBM's annual total return and annual risk. Okay, we use the same data set. So let's go back and we simply copy this in file. Okay, so this is our input file. Okay, so let's input pandas as PD. Okay, we are going to use pandas Python module. Okay, so I use equal. Okay, so data frame equals panda read underscore CSV. So this is in file. Okay, in file. So we are going to run it. Okay, so data frame head. Okay, so we input our data. Okay, we input our data, and so let's generate so-called so let's call it return. Okay, so we are going to generate a return column. Okay, so let's call it return. Okay, so this is so let's do it here. Okay, let's do it here. Then I'm going to copy paste back to the editor. Okay, so this is data frame. Okay, data frame dot. I'm going to use close. Okay, because eventually I'm going to replace close with just close. Okay, so data frame dot close, and they're so-called percentage. So we hit, after we type dot, we hit tab, and you will see this called percentage. So this is POPQ. So you will see the percentage change. Okay, so let's percentage change. Okay, data frame head. Okay, then we add the return. Okay, again, so this return only based close. We want base adjust close. So use up arrow key. So we have the year. So I'm going to show. Okay, so let's df head. Okay. So we have return, we have the year. Okay, we only use return the year to calculate standard deviation. Okay, so this is, so let's call it annual risk. So annual risk equals, we are going to use return. So we are going to annual risk equal df return. Okay, we are going to use group by. So this is df year. So we use year and we calculate standard deviation. So we calculate standard deviation. Okay, so let's run it. Okay, so this is our annual risk. Okay, so this is our annual risk. Again, so this is based on the standard deviation, okay, at daily return, okay. So we have to analyze. So times M SQRT 252. So we analyze. Okay, I'm going to run it again. So this is our calculate annual risk for IBM. For example, in 1962, it's 0.328526. Okay, I repeat. Okay, and so we have a data set. We use pandas read underscore CSV. We input. Okay, so you see we add the return, we add the date to, and we generate year. So actually, the most important is return and also year. Okay, then we use group by. So we calculate the. So if we want to calculate standard deviation, we use all the observation is df.return.std. Okay, then we calculate standard deviation based on all the return. Because we need to calculate annual, so we have group by year. So finally, we annualize our risk because this is based on the daily return. If based on the monthly return, then we need times SQRT 12. Okay, for the next one, we calculate annual return. Okay, so to calculate annual return, we need calculate and log return. So this. Okay, I'm going to I modify it a little bit. I use MP instead of mass. Okay, so it's the same. We'll have the same result. Okay, so this is annual risk. So this is annual risk head. Okay, then we get our annual result. Okay, so next one, so let's calculate annual return or annual total return or annual percentage return. Okay, annual percentage return. The first thing is we calculate log return. Okay, I'm going. So we are going to use NP. So NP log. So this is, as I mentioned before, we percentage return plus 1, then log. Okay, we are going to have. So let's look at the data frame. So df. So data frame. Then we have a log return, and also we have a year. Okay, it's almost identical to here. Okay, I'm going to copy paste here. Okay, so instead of annual risk, and we have annual return. Okay, so annual return will be our log return. Okay, so this is our log return. Group by year is same thing. Okay, so instead of it's a summation. So this is annual. Okay, so this is annual. I'm going to run this one first. Okay, so this is annual return. So actually, this is annual log return. Okay, so this is simply log return summation and by year. Okay, so I'm going to run it. So let's look at it. So this is annual return. Okay, so annual return. So this is our annual return. The first year is, so actually again, this is log annual return. As I mentioned before, and for the topic 1, we have to apply the exponential function. So I'm going to use, so this is MP, exponential function apply, then -1. So this is our final result. Okay, so exponential. So let's, I think exp, exponential function. Yeah, we got our result. Okay, so let's try look at the head. Okay, so this is our final result. Okay, so this is our annual return. This is our annual return in 1962. This is annual return 1963. Okay, I'm going to summarize for this one. Okay, and for we import two Python module, NumPy as NP, Panda as PD. Okay, for this part, and they are standard. Okay, we retrieve our CSV file, and we apply pd.read.csv. Okay, and for here, almost identical, and so we add the return column. We use percentage return function attached to the individual variable. So we use adjust closing. Then we use the PD pandas to datetime. We convert this to a true data variable. Then we retrieve the year. Okay, the final we calculate annual risk. We apply two things. Okay, so actually we apply std function attached to individual variables, and also we have group by because we group by year. And the last part is we annualize. We annualize because standard deviation based on the daily return. We have the time square root of 252 to annualize our standard deviation. Okay, the last part is, so this one is almost identical to here. Okay, and the first step is we calculate log return. Again, log return is simply our percentage return plus 1. Then we apply np log function. Okay, so after we, so last line will almost identical to this one. Okay, and we calculate log return. Okay, so log return, its summation, the log return summation will be total log return for the longer time period. So group by year. Okay, so this part will be our annual log return. Then we apply explain function -1. So this will be convert log annual return to log percentage return. Okay, so if you look at Excel, Python program, it's very, condensed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 lines. Then we calculate, we got our annual risk and annual percentage return. Actually, we can combine this line, put here, we can cut one line, and also we can combine these two together and make only like 8 or 9 rows. Okay, this is end of this video.